Okay, so I'll actually I have for today. Um, I don't have a lot of PowerPoint um, to bore you with, but I wanted to go through some examples mostly. All right, so let's, and actually a lot of this uh, is kind of going over things that I've talked about. The thing that about this is that when it comes to some of these concepts, uh, I mean, I can't just sort of present them or even you read about them and that's it. That's the end of it. And you get it and everything is copacetic. Some of these take just kind of going over a number of times, especially with examples. And I'm trying to give you examples that that kind of illustrate what's going on in a practical way as opposed to a, you know, abstract or academic way. So those topics, which all of which have been discussed and read about previously, but I'm going to hopefully give an example that will uh, illustrate some of this. Okay, one is this idea of method overloading. And I will mostly, for today's example, the illustration will be having multiple constructors, that is overloading the constructors. You can think about a constructor as a method. I mean, if you look at it syntactically, it looks like a method. It, you know, it has a name and it has parentheses. So that's what one of the things that distinguishes a method from a variable is that a variable doesn't have parentheses and a method always has parentheses. Now, a constructor is a special kind of method, and I'll point this out when I get to the examples. The one thing that, well, there are two things that distinguish it from other methods. The first is its name. The name of a constructor is always the same as the name of the class. And one of the things that Java did that was, I mean, I think actually beneficial was they welded together the name of a class, the name of the file that the class is in, and the name of the constructor. So those are all the same thing. That is the same name. And if you've you may have encountered a situation where you've defined a class in a file that had a different name. I mean, in NetBeans, that's kind of hard to do, but it is absolutely possible. And when you do that, Java totally freaks out. It just doesn't let you do that. So the method overloading we'll talk about today mostly has to do with constructor overloading. And then we'll talk about subclassing and overriding methods. That's something that's going to come up in Friday's exercise that I'm going to have you do. And there I'll say it and I'll repeat it later. What overriding is, as opposed to overloading, overriding is when you have a method in a superclass that you write in the subclass that replaces it. In other words, in method overloading, you have the same name but different signatures. That's what distinguishes them. In overriding, it's the same name and the same signature, in other words, exactly the same method as one that's in the superclass. We've actually seen examples of that already. The main example we've seen of that is the toString method. The toString method is defined in the object class, which is the granddaddy of all classes. So all classes in Java have a two-string method because they all inherit from object. If you write your own two-string method, though, as we've done with single card and as you're doing with the card deck, that's overriding. In other words, well, I mean, and that's actually kind of a very well-named idea, because you're taking in the superclass, if you don't override, then whenever whenever the two string gets invoked, it goes to the one in the superclass. But if you override it, then it does the one that you've overridden. And you've seen examples of that, but maybe not completely connected what's going on there. And I'll try to kind of discuss it, if not today, at some point, kind of what the virtual machine does when you invoke a method. What does the virtual machine do to try to make that method happen?
Is the benefit of doing that just consistency in the naming convention, or is it pulling any sort of information from that superclasses method?
Okay, great question. The reason you do it is there are a number of reasons why you might do that. The reason that we have encountered is that if you want to make sure, for example, take single card. How can you be sure that if I've instantiated a single card with a given suit and a given value, how can I be sure in a kind of easy way that I've given it the right values? Well, one way was I could call that the two getter methods. A much quicker way is to just print it. When you start using it in the card deck class, however, and I say, okay, what are the cards in the deck? Then I can just sort of buzz down the deck and just give the two string there. The two string in the object class is useless to me. It's just a bunch of gobbledygoo. The two string that I've overridden in the single card class tells me what the suit and the value is. That's the information I want to know. And the two string in the card deck class is one that says, okay, I just want to see what the cards are here. I want to confirm, for example, that when I've created a new deck, that it's actually created it in the way that I intended. So rather than writing for loops a lot, I write one for loop in the two string for card deck, and then all I need to do is just print the card deck, and then it'll all print out. And then later when I ask the question, well, I think I've shuffled it, but how do I know for sure? Well, I print it again. And if the cards come out in the original order, then the shuffle hasn't happened. And if they come out all mixed up, then that's good evidence that the shuffle has occurred. So it just, in this, how we've been using it so far is mostly for convenience. And when we get to more sophisticated designs, there are inherent reasons why it's very useful. Okay, and then finally, I'm going to give an example where the overloading is going to be for constructors, and in accordance with that, I'll show you what this super and this business is about. The difference between we've seen this as well. I mean, and this is in my opinion one of the worst named things in Java, because this usually is that thing over there. This actually refers to the object that you're in. One of the few places where I feel that Python has done a better job than Java, there aren't many, but one of them is in Python, instead of this, they say self. And to me, that's a much better way, that, because self clearly indicates that it's the object that you're in, the self. This is like kind of, what the heck is this? But we're stuck with it. Okay. Okay, again, method overloading, and again, it's important to kind of understand this. From a design standpoint, it comes up a little bit. One of the challenges, I mean, I've been doing a lot of Python programming lately, and Python actually doesn't support method overloading, which is a little unfortunate, but it doesn't. Python is not as object-oriented as Java. It's not an object-oriented language and it's inherent, but that's not what this class is about. This class is about Java, method overloading. We have actually mostly seen method overloading with the things like the print line statement, the print line method. The print line method works for strings, it works for objects, it works for all the primitives. And the way that it works for that is that there is a different print line which is defined in the print stream class that has each of those different signatures. Maybe at some point I'll actually show you what that is. Now, one of the little gotchas here is that the return type is not part of the signature. Okay, so this word signature is a keyword when it comes to referring to Java. I mean, in the sense that a signature is a very specific term. And what a method signature is the list of types that you call it with. So a method with an empty signature, a method with no arguments has an empty signature. A method, say, that has a string signature, a string when you call it, has a string signature. The single card constructor, for example, had a signature of an int and a string. The int was the value, the string was the suit. So its signature was int string. Now, one of the reasons for why object-oriented programming gives you more flexibility than sort of the single file thing is that if I have two different classes, I can have identical methods in each of them that probably do different things if they're in different classes. And they may have absolutely nothing to do with each other. So that's it's not overloading or overriding. They're just different ones that happen to have the same names and signatures. That's absolutely legal. Within a class, however, I cannot have two methods that have the same name and the same signature. And that should be fairly obvious. Okay, so like methods, constructors can be overloaded, and we'll see an example of this. So you call the superclass constructor with a call to super. You call another constructor in the same class with a call to this. And the thing is that call has to be the very first executable line in the constructor. The very first executable statement in the constructor must be either super or this. No exceptions. And if you don't put one in, then Java will put in a call to super with no arguments. Now, given that you can have multiple constructors, this is what I consider to be the best practice, and one that, in my experience, is every once in a blue moon to be violated. Like all rules of thumb, it isn't necessarily 100% applicable. This is like 99.9% applicable in terms of a best practice. And that is when you have multiple constructors, you have only one that calls super and all the other ones call this. We'll see an example of that. Okay, so here's the example that I'm going to show you. So here I have a super class. I'm modeling, what are we doing here? Well, we have pets. So, and obviously they're, we chosen the two most popular pets, cats and dogs, but there are also hamsters and gerbils and snakes and hippos and rhinoceroses and elephants, and the possibilities are almost limitless. Okay. So in designing something like this. And again, this is just a more of a class exercise than anything else. But the idea is here I'm going to have cats and dogs. Okay. What are the things that I want to have common to all of these? Okay, and the ones that I've chosen, again, just for a simple example, are the name and the breed. Okay, so every pet that I could envision is going to have a name, and it's going to have a breed. Okay. So the idea is, okay, now the pet is going to have a single constructor, which is if I have a name and a breed, then I want to make sure that it has one. My name and my breed, I have getters, but not setters. That is once, and so we're not going to let ourselves rename the pet. And we certainly can't rename the breed. Now, you could make a case for having a setter for the name, because you say, well, what if we wanted to rename it? Or what if we're adopted by someone else and they wanted to name it something else? So again, there would be a case for a setter for that, but again, we're just trying to make I'm trying to make a very simple illustration here. And what we're illustrating are overriding and overloading of constructors.
Can you, sorry, I hope this won't derail it, but the purpose of the getters, I mean, I understand like you can invoke the function and it gives you, and if the return is just the name back, but I mean, can't you just have it like print out the name or just use the actual variable name? I'm not totally sure I understand why. It seems like an extra step, and I don't totally understand why we have it.
Okay, now remember we talked about what private access means?
Mm-hmm.
Okay, so what does private access mean?
You can only access it within that class.
Right. So if I'm in another method, say like even the main method, and I have a reference, I have a pet, and I want to know what its name is, how can I find that out? In that other class, I cannot access these because they're declared private. And that's the principle of encapsulation. Because if I can directly access these variables, then some other object could change them. And I don't want that. You say, well, just don't do that. Here's the problem is that whenever that is allowed, then it is inevitable that by accident, typically, it's usually not by design, but by accident, it gets changed. And if you remember, I showed you an example of how that could happen with an array. Whereas if I get an array and I get a direct reference to that array, then if I change a value outside of the object, then it changes it inside the object. And that's a violation of encapsulation.
Okay, yeah, that makes a lot more sense. I was missing that.
No, and you're absolutely right. It's extra work, and that's it. Always, and it's good that you're asking this, because it's whenever there's extra work, it should be questioned. Is it worth it? Is the extra work of making these variables, instance variables, private, and only allowing access by special methods, is that worth it? And many years of experience with this has shown that it is. So but that, I mean, excellent question. Excellent question.
So the only time we'd use those getter methods is outside of that class, right?
Correct. Yeah. And in other words, and this is sort of the loose concept of interface. Later in the course, we'll talk about a more strict concept of interface. The idea is that if I have one of these objects, then what messages can I send it? So so what this says is the messages I can send this object are, I can get its name and I get its breed. And when I send it that message, it will give me back what the name is or what the breed is. And that's it. Well, the toString, I send it a message toString and it will return a string that represents what these values are. Okay, does that answer the question? In other words, methods.
That clears up a lot. I think, yeah, I'm good. I think that clears up a lot of things that I was not totally grasping.
Yeah. So the thing is, the methods are what you're signaling to the world that anybody who has a reference to this object can send a message of that name or invoke that method. Okay, so let's look at, so we have two subclasses here. Okay, remember, every class can have only one immediate superclass. Of course, there's the object all the way up here. So all the way at the top, there's object as well. Okay. All right, so you can only have one immediate superclass, but you can have as many subclasses as you want. So here are two. Here's cats and dogs. So cats and dogs are, in this context, we're going to consider them pets. But now, okay, so why do this? There are a number of reasons why you might do this. In the case of a cat, for example, there are things that a cat does that other pets don't. Okay, one has to do with its instance variable. So so a cat will have a feature, say it's either long hair or not. Okay, again, a simplistic, it's a fairly simple way of distinguishing it, but that's one way that you distinguish cats. The other is kind of behavior. So a cat will meow, whereas other pets will not. So I can, if I have a cat, I can say meow. But if I have a dog doesn't have a meow. A dog has a bark instead. Now, this is the getter method for a Boolean. And the convention is that if I have a Boolean variable, the convention is, instead of get long hair, it is long hair. And that's just because it sounds more Booleanish. The convention for getters for variables are get and then the name of the variable with it capitalized. So a dog has another instance variable called large. So there are large dogs and small dogs. So you're either a Great Dane or you're a poodle or a Chihuahua or something. Okay, so a Great Dane presumably would be large. A poodle would be, or a Chihuahua or something would be small. Large would be false. Okay, so, and again, its getter is large, and dogs have a bark. And then the other thing that this is illustrating is method. I have two constructors here. So one is a dog with just two strings, and another is a dog with a string, and a Boolean. So the Boolean is going to be whether it's large or not. And likewise with a cat, it's going to be string, string, or string, string, and Boolean. And again, this is just for illustrative purposes. Okay, so how okay, yeah. Oops. Yes, it'd be. I was having computer issues myself this morning. These infernal contraptions. Okay, I'm mindful of the time here. I will try to let you out early. And let's close that. Oops. All right, sorry. Okay. All right, so let's we'll start with let's see if I see a way I can get them both going here. Sorry, let's maybe if I share the whole thing. Do you see? Can you see this? Yeah. Okay. So this is what I want to implement here. So now one thing I want you to also kind of pay a little bit of attention to here is how I write this class, and that's the way that I would recommend that you write classes as well, because in my experience it has proved to be the most the way that gets me to the finish line with the least amount of angst. Okay, so right, the name of the class. So from the UML diagram, the name of the class is specified. So pet comes right from this. Okay. So first, create your class and give it the right name. Okay. Check. Second, write the instance variables and generate any of the setters or getters that you require. That's the second step. Okay, so in this case, and always private. Okay, so that's step 2. Step 3 is to, well, actually, step 3 is to actually write the constructors. That's, so let's look at the constructors. We have one constructor, which is, again, the name of the class. And if you're, again, I like using the same name, but notice the different colors. You should be mindful of the colors in NetBeans because they give information. See, this name is in black, and that shows that it's either an argument or a local variable. This name is in green, which shows that it's either an instance variable or a class variable. But okay, so okay, oops. Okay, so that's so, and if there were other constructors, I would write those as well. Now, and if there was something else to do in the constructor, then that would also put it there. Okay, now here's for generating getters and setters, there is another magic incantation that you can use, and it's called refactor. So in this case, I'm just sort of selecting the variables that I want to generate my setters and getters for. I'm right-clicking, I choose refactor, encapsulate fields. And okay, so here, okay, I don't want these setters, but I have these two getters. And here, this is where NetBeans kind of puts them in weird places. I want to make them the last method. And I hit refactor and look at what it's done. It's generated them for me, and that, you know, I don't know about you, but I tend to fat finger things. And so that's this, if I'm just generating them like this, then that prevents my fat fingering. So I highly recommend that you do that. And the thing is that if
How did you do that again?
pardon me?
How did you do that again, real quick? Just
All
the
right,
button.
okay, so yeah, so here's the thing is that, okay, let's delete these. If I just right click anywhere and I choose refactor, encapsulate fields, it's all the way down. It brings up a little thing here. So here are my they call them fields or instance variables, same thing. And I can choose, in this case, I want the two getters. The main thing here is I want to keep the fields visibility private, but the accessor, and that's their word for getter and setter. Accessor means getter or setter, as public. And so rather than the default, last method is usually what I put, or I can insert it absolutely anywhere. This, like if I want to put it after the constructor, it'll be the same thing. And I hit OK, and it generates it for me. So when you say, I mean, you know, before you say, well, isn't it a lot of extra work to have all these getters? And the answer is, with this refactor encapsulate fields business, it's a couple of clicks. So that's not a lot of work at all in my book. Okay, the final thing is the toString. And this is method overloading because, okay, so now what do we want to say? So this is, we just want to, and it's always useful to, we'll talk later about what these things are. You're not responsible for them yet, but this thing is called an annotation, and that's, it's not required, but what it shows anybody who's reading this, that this is an overridden method. Okay, and notice the terminology, override. It's, in other words, this method is overriding something that's in the superclass. In this case, it's overriding the toString method in the object class. Okay, so, and now at this point, I want to kind of test things out. Okay, so how can I test something out? Okay, so okay, so I want to create a pet. I'll call it Dolly, and its breed is going to be a Manx. All right, and as you can see, we have the red squiggly here, and it says it cannot find the symbol. So when you encounter that, and you no doubt have encountered that a fair amount, when you have the name of a class and you know that that class exists because you just wrote it, and it says it can't find the symbol, what that means is all it's missing is the import statement. And the best way to do that, again, is not with trying to type it in, but there are a couple ways of doing it. One is to right click and say fix imports. See, so, and when it found it, if it finds more than one, it'll throw you up a little dialogue and say, hey, you know, you got to pick one. The other way, which is a little more fine, is that you notice here that there's a little light bulb. Again, light bulbs are always useful information. Again, cannot find symbol, cannot find symbol. But when the light bulb has a little red dot on it, that means you can click it and it will give you some options. And here are the options. I can add an import. I can create a class in here. I can create another class here, create class here, create class here. And what I want here is an import. Oops. All right, so what am I doing here? Like the principle is this, is that don't write a whole lot of code before testing it. Now, in this case, there's not a whole lot of code, but you know, I want to test things as soon as possible. So here I just want to confirm that what I've done is actually made it through. Okay, so check. So now I can move on to the next one, which is, okay, let's do the cat. So here's how you subclass something. I say new. Okay, the name comes from the UML. So the name in the UML is cat. Okay, so I have a public class cat. Now, how do I subclass pet? I use the word extends. Okay. Now, it's giving me it's giving me a red squiggly, but again, always check out what it's telling you. Look at this. It says constructor pet in class pet cannot be applied to given types. Required string found no arguments. Now, do you remember why it's giving me that message? So did you remember why I'm getting this error message?
Is it expecting two strings as parameters?
Well,
Do you have to import pets?
no, you don't have to import pet because it's in the same package. Okay, if you remember yesterday, I said, what does Java do if I write a class and it does not have a constructor? I don't write a constructor. Do you remember what Java does?
It makes one for you.
It makes one for you. And when it makes one for you, what is the first call in a constructor? It's either super or this. So Java writes a construct. What's happened here, again, there are two things. One, I didn't write a constructor and Java said, oh, you don't have a constructor? I'll put one in for you. Thank you very much. And then it says, oh, your constructor doesn't have a call to super or this. So I'll put a call to super in with no arguments. So that's what's causing the error. So it's important to kind of, you know, don't freak out at these and don't try to start flailing around. Understand what the error is and what's going on. This is a very common error. If I'm subclassing a class that has a constructor with arguments, then I'm always going to encounter this when I first start writing. And the solution is to make sure that I write my constructor to at least have one constructor that has the same signature. And now my call to super A call to super calls the superclass constructor. Okay, when I call a constructor or any method, I need to give it the right arguments. So the pet constructor requires a string and a string. So here I've written a constructor in the subclass that also has a name and a string and a string. And my first call is to super, passing the name and the breed. I can't just do this. See, if I do that, it says cannot be applied to given types. And this is very, it'll really help you if you understand this message, this type of message. It says required, because this is telling you everything. It says cannot be applied to given types. Required string found no arguments. Reason actual and formal argument lists differ in length. So here it goes away. Okay, so now going back to my cat again, it has a second constructor, but before I get to that, I want to do the instance variable. So let's do that. Okay, and now I can do another refactor, encapsulate fields, and again, I want the getter method for that, and I'll put it as the last method. Okay. So what else do we have? We have the I have the is. I've done the long hair. Okay, now let's write the second constructor.
Sir, does it matter in the order if the private Boolean is above or below the super constructor?
It doesn't matter as far as the class is concerned. It just what I prefer in terms of it's just a preference, and it's a, you know, I like to have the instance variables, then the constructors, and then the methods. That's, you know, so if you like it otherwise, then that's fine too.
Thank you.
Okay, so what are you complaining about? Okay, again. All right, so now here I have two choices. But remember, I said I already have one that's calling super. So for this constructor, when I call this, what that does is when I say this and I give it name and breed, that calls this constructor. Okay. So now what I need to do here is that, and you know, remember a Boolean is, okay, I'll make the default a one of these. Okay, so here, if I want it to not be a long hair, then I have to say it's not. Okay, and I'll finish this tomorrow because this is I think hopefully this is giving you useful information. Okay, again, getting back to this, we have everything except meow, but I want to do the toString here. And so here's how I have in the superclass, I have the name and the breed already. So I already have that string. And so, and I think somebody might have mentioned this yesterday, I can call the immediate superclasses method like this, super.toString, but I want to concatenate that with the variable. So now I'm overriding an overridden one, but I'm using, and I always have this choice. I can use what is in the immediate superclass. I can't go up 2 levels, but I can use what's in the immediate superclass. And okay, so, and then finally, and now I'm going to do something that I'm not going to let you do, and that's put a print line. Okay, what I've done here, remember this, notice this is in blue. So blue is a keyword. So here's how I can test it out. So let's create a cat. Oh, what is a short hair? Just call it that. Okay. All right, again, cannot find symbol. The solution, first thing to try, just right click, say fix imports. That should always do it. Let's meow it, okay? Okay, so I can meow the cat. All right, so there's more to do. I will finish this tomorrow. But if there are no burning questions, I'll let you go so you can get ready for your next class.
I had a question. Is when you create in the constructor, when you make the super object, is that kind of like saying that you're creating an object of type whatever the superclass is?
No, you're simply calling the superclass constructor. By instantiating a subclass, that the subclass actually is the same type as the superclass, or I mean, is a compatible type with the superclass. In other words, if we look at this, a cat is a pet. A dog is a pet. But a pet is not a cat.
So are you using the superclass when you only want to pass in the arguments that are in the parent?
I'm not quite following.
Like if you want to create a cat with 2 strings and no Boolean,
Correct.
use super because it only requires 2 strings and no Boolean.
Yeah. In other words, this call.
I'm sorry, I can't see your screen.
Oh, I'm sorry. Okay. This call calls the superclass. I could I could have done this. So you notice this works as well here. So even though this constructor also had a Boolean, it also had the name and the two strings that I could call the super with. But this is, I mean, it's for a simple class like this, it's not the biggest sin, but it's much preferable to use something like this.
Just so I understand, like this refers to like the constructor inside cat. Like,
Yeah, this calls the cat constructor with two strings.
Mhm.
Super calls the pet constructor with two strings.
okay, that makes sense to me.
Okay. Okay, so we'll see you tomorrow.
Hey, sir, I got one question.
Oh,
Will you be-
okay. Right,
will you
shoot.
be posting the Friday's assignment before Friday, or
If you like, I could post it Thursday afternoon if you really want to kind of get a head start on it.
yeah, that would be great. Thank you, sir.
Okay, sure enough.